Hi, welcome back. Let's continue our discussion on feature transformation. By the end of this video, you will be able to explain and perform categorical encoding. Categorical encoding is a variable transformation technique for the categorical variables. It is primarily of two types: one-hot encoding or dummy encoding and label encoding. In dummy encoding, we create a separate dummy feature for every level present in the categorical column. As a result, number of total features increases in our dataset. As we have seen previously, dummy encoding one variable condition of the house resulted in 4 new dummy variables. The benefits of using this encoding is that it is dead simple. Moreover, the model detects the relation between the individual categories by itself using the gradient descent. But the downside of using the dummy encoding is that it may increase the dimensionality, that is, total number of variables of our dataset. Having too many features inhibits the optimum learning for any model and therefore is often recommended to avoid creating dummy variables for the categorical features with many categories. To counter this with, we can use the concept of binning, which we will look over shortly. Now let's look at the label encoding. Label encoding is used when we want to preserve the existing order among the different categories of columns. For example, let's say the order in the feature condition of the house is bad, okay, fair, good, excellent. In this case, we are very much aware of the relative order between the different categories of the variable. Therefore, we can label encode them as bad equal to 1, okay equal to 2, fair equal to 3, good equal to 4, and excellent equal to 5. In this case, we can avoid creating a new column for each level in our categorical variable. As a result, the dimensionality, that is the number of input variables of the dataset, stays the same. In this case, we can avoid creating a new column for each level in our categorical variable. As a result, the dimensionality, that is the number of input variables of the dataset, stays the same. However, you should use label encoding only when the order among different levels is known to you, or else it may lead to model learning the incorrect information. Let's open the Jupyter notebook to perform label encoding. We start by copying the column condition of the house in the variable label encoded. Then we use the .valueCounts function to find out the number of instances in each of the categories. Next, we perform the label encoding. For this, we use the map function and we pass the dictionary of the encodings that we want to have as a dictionary. If we again use the .valueCounts function, we can clearly see that all the categories in string format have been converted into numerical format. Note, the encodings, they are in the same manner we define using a dictionary. So that's all about label encoding. In the next video, we will discuss another feature transformation technique called binning.